think about your group work from the various viewpoints. So now I'd like to start. So yesterday I show you, would you please next slides, please? Yeah, so yesterday I showed you the example of the energy management system in Utsunomiya City in Japan. So in this model, the center of this energy management is the local energy company. So if you are the staff of this local energy management company, what should you think about the energy management to complete the energy management? So in this case, this local energy company purchased, thank you, here, this one, okay. So this energy company purchased the electricity from the local power generation plant by waste. And in addition, they purchased the electricity from the residential sector, from the buildings, about the excess electricity from solar power. So they purchased both of the waste to power electricity and the excess electricity from solar power. And this company buy their electricity to the public electric vehicle company, bus company, and also they sell the electricity to other buildings, such as public buildings and so on. So in this case, what should you think about the complete the energy management in this model? So please next slide. So the most important thing is the balancing both of supply and demand electricity on real-time basis in the electric grid system. So you have to meet both of the electricity supply and demand amount on real time. For example, the company staff have to meet the energy supply and the energy demand in every 30 minutes. So this kind of important work to balance both of the supply demand balance can be the model constraints. So in the simulation model, we set this kind of constraints in the simulation model. So as a first step, please design a whole of the energy management system, and please think about what should you think, what should you control the energy balance, okay? And in the design of the energy management system, the departure of the development of the simulation model, you have to set the objectives. So in this system, what is the main target? So for example, some energy company wants to minimize their energy cost on business, or in some cases, they want to minimize the energy consumption in this area, or they want to minimize the energy losses in this system. So this kind of objectives setting is the departure to develop the simulation model. Or in this kind of optimization model, you can set the maximization objectives. For example, of course, this system should be maximize the economical benefit, or the social benefit can also be maximized. What is social benefit? For example, the hiring the local people or carbon dioxide emission reduction is also the social benefit. So not only about the economical benefit or cost, you can set this kind of social cost or social benefit as an objective function, objective variables. Okay, so this kind of target objective is called as objective variable in the simulation model. And this objective variables is defined by objective function. For example, if in case of that you want to minimize the energy cost is the objective variables, and this objective variables energy cost can be defined by this kind of energy objective function. For example, energy cost X equals to initial cost per year plus maintenance cost plus fuel cost. So this kind of formula is called as objective function. So this function is defined the objective variables X in this simulation. So next, please. And after setting the objective function, you have to collect the data to calculate the objective function. For example, in the power company businesses, you need the solar power generation amount kilowatt hour per 30 minutes per 1 kilowatt output of solar power. So this kind of data you need to calculate how much amount of solar power generation electricity can be obtained to this local energy company. And at the same time, you need the electricity demand on Surabaya City Hall, for example. The unit of this electricity demand is also the kilowatt hour per 30 minutes. So I just show you the example of that collecting data. So this kind of data, if you can obtain this kind of data, you can calculate by yourself about the energy management system, okay? And also in the Utsunomiya case, they purchased the electricity from the waste incineration plant and the excess energy from the solar power, and they sell their electricity to the public buses company. So you need the demand side electricity amount. So to calculate the electricity demand in the buses, you need the data of the driving distance by public bus. The unit is kilometer per day. And the electricity consumption efficiency of electric vehicle bus. The unit is kilowatt hour per 1 kilometer driving. Okay. And also, you need the electricity charging device capacity for electric vehicle bus. So these kind of data is necessary to calculate how much amount of electricity electric buses need. And after obtain this collecting data, for the calculation of objective function, you need the cost data. So for example, the initial cost of solar power and EV bus, for example, the unit is rupee per bus or per kilowatt of solar power installment. So this kind of data collection is necessary to calculate the objective function. So in the group work or the excursion to the city, maybe in tomorrow, not tomorrow, but Saturday, Sunday. Okay. Yeah. In this afternoon, thank you. In this afternoon, we will go to the city council. So please ask about the data, okay? And after collecting the data, you have to set the variables. For example, if you can't decide it yet about the installed capacity of solar power, this can be the variables, okay? Or if the company have not decided how many buses should be changed to the electric vehicle from the conventional gasoline buses, this kind of number of public buses converted to electric vehicle bus can be also the variables, okay, in the simulation model. And after setting the variables, you can also set the model formulas and constraints. So I utilize these constraints words again. So I mentioned about the energy demand and supply balance can be the constraint in the simulation model. So I just show you the example of the balancing formula. The electricity demand on City Hall plus EV bus charging electricity amount should be balanced, so should be equals to the sum of electricity supply from solar power plus grid system purchase electricity plus yes. So sorry, the grid system can be converted to the electricity purchase amount from the waste incineration plant. So this kind of energy demand should be meet to the energy supply amount. Okay, so this kind of formula you have to set in the simulation model. And also as a constraint, another constraint, the EV bus charging electricity amount should be less than the charging device capacity. So in the charging system, you can just put the, how can I say, the charging plug to the electric bus, but the charging plug can only, for example, the 200 volt in electricity. So it has the limitation to the supplying electricity amount at the time. So you need this kind of the charging constraint is also needed. So this kind of the constraint and the formula setting and the variables setting and collecting the data, then you can calculate the objective function. So this kind of total management, how can I say, the total design is necessary to develop the simulation model. So please remember, if you develop by yourself about the simulation model, you have to collect the data and think about what kind of constraint or what kind of formula can be should be needed in this system. Okay, so please next. Yeah, so as an example of the simulation model, for example, the Utsunomiya case, they already have the conventional buses routing system, but some of the buses can be converted to electric vehicle, but how many electric vehicle can convert from the conventional buses? You need this kind of simulation. So in additional, as an additional information, you need the conventional bus scheduling also data and the population flow data. So many data are needed to calculate the optimal routing or optimal charging points or optimal number of electric vehicle buses. So this is a kind of the example. And please, next one. Yes. And if you calculate or think about the simulation model of total energy balance, including the solar power utilization, there is so many options, actually. So I would like to show you some example in Hamamatsu City in Shizuoka Prefecture in Japan. So they developed the energy model utilizing the PV so they try to connect the solar power with the key public facilities by private power lines for disaster resilience. So we have so many earthquakes and disaster in Japan. So in case that's the blackout, they need, for example, the hospital or the community center or park for the evacuation site. So this kind of key public facilities needs every time the electricity or energy. So in this city, they develop the local electric grid system by themselves and share the solar power electricity to that kind of key facilities. So yesterday we check about the demerit, so disadvantages of the solar power or renewable energy. And most of the students answered the most problem is the cost or economic problems. But from the viewpoint of resilience, the cost is less valuable than our human life or human, how can I say, the alive. So the resilience is one of the key points to install this kind of renewable energy. Okay, so Hamamatsu City, they developed this kind of grid model to connect the solar power and the hospital, community center, and the cultural hall, and the energy supply on this grid model is from the solar power and the waste to energy plant and the wastewater such as the sewage purification center. So they install the biogases fermentation plant and produce the electricity by combustion the biogas. So this kind of local energy utilization and the local energy consumption model is necessary to improve their resilience as the disaster time. So please next. And in case of the waste to energy plant, if you want to increase the electricity efficiency, production efficiency, the waste separation process is very important. Okay, so we emit the garbage, including both of the organic waste and the plastic waste and the paper waste, but the calorie of the waste is much higher in the plastic and the paper. So separation process is very necessary, but at the same time, if the garbage company collects the waste in the city, they have to 2 times in case of the separation system is working. The one time is for the collecting organic waste, and second time is the plastic and paper collection. So it means the collection cost is increasing. So we need to improve the energy efficiency, we need to think about the optimal collection routing system at the same time. So this kind of simulation is also necessary. So not only about the energy management, but this kind of collection routing optimization, or think about the possibility of power grid connection, or possibility of cooperative waste treatment with the next cities. Okay, so there's so many kinds of simulation models. So please, the last one. So this is the last one. Okay, so this kind of various simulation model is existing, and you can develop if you can develop this kind of simulation model if you design the system and collecting data. Then please set the objectives. What the system is needed, what the goal of this system. Then you can calculate by using the data about the objective function. So thank you very much. This is the outline of the simulation model. Thank you.
All right. Thank you, Prof. Iwata, for the informations on the simulation model. So, students, is there any questions for Professor Iwata about the simulation model? Yes.
Thank you for the opportunity. So, Professor Iwata, this topic is really interesting because there is optimization in the energy management. I also have studied about optimization in especially the industries. I was wondering, have you ever tried like the various algorithm to do the optimization? For example, particle swarm optimization, generic algorithm, like that kind of optimization. Have you ever applied those algorithm of optimization to the energy simulation? Thank you.
Yeah, thank you very much for your question. Actually, in my laboratory, we developed this kind of optimization simulation model. The target of the objective function is, for example, the economic benefit maximization model in the agri-solar power generation system, connecting the agriculture and the solar power company. So that kind of simulation model we developed. But sorry, I don't prepare the details slides.
Oh, yeah.
Actually, yeah.
That's okay. That's okay.
Yeah. And the other one, not the optimization model, but we called the multi-agent simulation model. So in the multi-agent model, we set each variables per each person. So the simulation model can calculate each person's behavior in the simulation model. So by using that model, we calculate the optimal EV charging system in the city. So EV is driven by each person. So each person have the different behavior. So we collect the various data about the driving behavior and inputs the data to the multi-agent simulation model, then calculate what is the optimal charging spot in the city. So that's kind of research we do.
Oh, okay. Sorry, I have a backup question, follow-up question. Sorry, this is a bit technical. So regarding the function, is it linear or non-linear model?
Both, actually.
Both?
Both,
Oh.
Yeah. Linear model, it's very easy to calculate. The simulation time is very shorter than the non-linear model. But the non-linear model, sometimes it's necessary. Yeah. So both of the model we have. Yeah.
Okay, thank you so much for the answer, Professor Iwata.
Welcome.
Okay, is there any other questions? Yes.
Thank you so much, Professor Iwata, for your lecture today. My name is Aliyah, and I'm from Architecture Department. So it's actually my first time hearing about this topic, and actually there's quite a few of architecture students here. So my question is, Do you know how to colorate this with my major, since I'm not very familiar with this? Yeah.
Sorry.
Do you know how am I gonna colorate this topic with my major, architecture?
Architecture.
Yeah.
Okay.
Connecting this simulation model into architecture
Yeah,
field.
Yeah.
Maybe I have another slide, isn't it? There's no more. No. Yeah, this one. Yeah, sorry. So, it's not reflected. Yeah, in the architecture field, this kind of optimization simulation model is developed. For example, on the rooftop, they need the solar power, and at the same time, how much amount of the solar radiation is needed. So to define the, can I say the 桂水先生、方角って、方角え direction, sorry. Yeah. So the direction of the solar power and the size of solar power and the, how can I say, the vertical, yeah. So that kind of many variables in this simulation model. So architecture, of course, can be applied. And also, not in my research field, but in the architecture field, they calculate the optimal design of the inside of the buildings. And in that case, the objective function, objective variable is the maximizing the comfort, human comfortable. Yes. So, yeah. But it's very difficult to collect the data about the human comfortability. So, but it's a challenging research, but I think it's very, interesting. Yeah. Thank you. And actually, sorry, did you? Yeah, and actually, in this kind of building model, in this group work, you will learn about the green building. So, in case of the think about the green building, you have to also think about the human behavior change for energy saving, as the lecture from Professor Maria yesterday, and the electrification of hot water supply in Japanese case especially, and also the high incineration is very important to saving the energy from the air conditioner. So, and the passive design is also very important. What is a passive design? That is a utilization of natural wind flow or natural sunlight as the lighting. So today we put off all the lighting, so utilize the natural sun lighting. And also the garden trees utilization is very effective. For example, in the summer season, we don't need enough so much sunlight because it increases our room temperature. So if we can cut the sunlight by trees, it's very eco-efficiency. Okay. And in the winter time, actually in Japan, we have so-called winter season. So in the winter time, we need sunlight. So if the leaves of the tree will drop in the winter season, we can get enough sunlight, and it can contribute to increase the room temperature in winter season. So that kind of natural resource or natural facility can be utilized in this passive design. Okay, thank you.
Thank you so much, Professor Iwata. Is that clear to your questions? All right. Thank you. Is there any other question? Maybe from Japanese students, if you have questions as well regarding this presentation about the simulation. Okay, no questions? All right, as there is no questions, I would like to give time to Professor Maria to give another informations related to the simulation sessions. And maybe we can give applause to Professor
please
Iwata
give a very wonderful
for
applause
the
to Professor
information.
Iwata. I took a note at the back, and I think the topic that you are explaining is very, very useful for the project that we are doing. Okay, Ruben and Fabi, could you please distribute the paper? Yeah. Okay, everyone. So now I will bring you directly to implement what Professor Iwata just explained. Because maybe listening to the explanation without using your motoric skill to draw a picture and calculate things is not really make you understand what's discussed before. I just wonder, have you been sitting in your group? In your group? Okay. So now I will go back from here, just taking what Professor Iwata explained, everyone. So first of all, we have to set the objective. Okay. What's the goal we want to achieve? Now I put you in a case study. The case study, Rian, could you please go to my slide and go? Yes. Okay. This slide, Rian, go up. No. Go down, sorry. Go down to the numbers. Yes. And make it bigger, please. Okay, everyone. So I will put you in a case and then you start discuss with your colleague and make the modeling. Okay. All the students in the Zoom, you also need to do the same. City Council has 864 cars. City Council has 864 cars. It consists of ambulance, 113, and then operational car, the normal car, 657, and then patrol car is 94. Now we concentrate on this one, 657. And then 657. Remember, yeah? 657. Okay. Now, if City Council want to change all of those cars to be electric vehicle, this is the normal vehicle. This is the normal vehicle, and they want to change into electric vehicle. Could you please tell me how many cars that can be changed if in 2025 the budget is 10 billion? Okay. Ruben, could you please bring the whiteboard here so I can write down? Okay, everyone. So the paper already given to you. I give you opportunity to discuss with your friend how to develop a model to calculate those conditions. Okay. The number of car 657 unit. Dikunci di sini, Ruben. 657 unit. Normal car. Okay, normal car. You have to make assumption. What is the type of the car? You may choose, for example, Toyota Innova, maybe. Okay, most of the cars are actually very similar with Toyota Innova. So this is the number of car. If you want to get down to the information, car that already over 7 years old, and then some cars is still new, less than 7 years. The car that less than 7 years is 191. And then older than 7 years is 466. Okay, could you please go back to Professor Iwata's slide? And now all of those cars using petrol. using gasoline, right? And now we are going to change. It is actually the desire of the city government. They want to change all of them to electric vehicle. Set up the objective function, the goal, and then go for the variable. In this case, we want to calculate the number of car that need to be converted into electric vehicle. Okay, and then you have to find data. How much electric vehicle that equal with Toyota Innova function. Okay, and then you have to set formula. We have constraint. The constraint is the budget owned by the government is this amount in 2025. Okay, guys, I give you time now. Please discuss with your colleague. Make the modeling now. Come on. You are given paper, so write down the formulation, talk how to solve this problem, how many cars that need to be converted into EV. Mbak Fai, if you can share the PDF of this slide, is already? Okay, student in the Zoom, you also have to do the same. And later on, bit by bit, the case will be extended. How about if we use ambulance? How about if we use fire brigade cars? Okay. 10 minutes, everyone, to do 5 minutes to discuss, 7 minutes. After 5 minutes, you can explain the modeling and you can have better idea about the modeling and simulation. Sudah dikirimkan ya? Di WhatsApp-nya kita tolong kirimkan ya, Pak, supaya saya bisa. Anyone finish the modeling? So, what is the objective? Remember the objective. And then what's the setting variable? In this case, we have 466 cars over 7 years, 191 less than 7 years. We want to replace that car with electric vehicle. The budget is 10 billion. So what is the objective? What is the decision variable? What's the constraint? And then how's the modeling? Come on. Let me ask couple group, what's the objective that you want to achieve? Okay. Okay, maximize the number. If you want to maximize the number, you just take all of them and put it in the equation. However, the objective is beyond that. Everyone, please pause a while, your work, please pause a while. I'm going to discuss with you the objective, okay? Because it is very tricky to define the objective. If your objective, I talked with two groups, and they said that the objective actually to maximize the number. Hang on. Everyone, what is behind changing traditional car to electric vehicle? What's the aims? What's the goal? Why we want to change? The car is still okay. The car can work properly. Why we want to change normal car to be electric vehicle? Remember Professor Iwata lecture about decarbonization, right? We want to change the car, the original car, into electric vehicle because we want to reduce the CO2, right? We want to reduce the energy usage, right? So the objective is minimizing emission, minimizing CO2 emission, right? Minimizing energy use. Get the point, guys? And then the decision variable is number of car that converted into electric vehicle. Got the point? So number of car converted into electric vehicle is not the goal. It is the variable, decision variable. It is not the goal. If it is the goal, just make them all, just convert them into electric vehicle. However, we have constraint. The constraint is the budget, right? So what is the goal? What is the objective, guys? Mas Rian, boleh? Freeze-nya dicoba dulu. Yeah. Okay, everyone. So the objective here, see, can you make it bigger? Minimize energy cost, minimize energy consumption, maximize economic benefit, right? Maximize social benefit. In this case, the objective is to minimize the CO2 emission. And then the setting variable is, Jude, what is the setting variable I mentioned before? Ayo, fokus, fokus. Apa, Jude? Apa, Belva? What is the decision variable? The number of car converted, right? The number of car converted. And then what is the constraint? The constraint is the budget provided. Okay, everyone, now you have better understanding about the energy modeling. Okay, the objective is, ayo, the objective is the CO2 emission. That means what kind of data you have to collect. You have to collect the amount of CO2 released by 1 liter petrol, right? How much CO2 emission released per liter gasoline, right? And then you also have to find data on how long the distance, the driving distance of each vehicle. How long is the distance, driving distance of each vehicle? And then you also need to collect what kind of data? The efficiency rate of car. For example, if your car is old, 1 liter can be used for 10 kilometers. But if your car is newer, 1 liter can be used for 15 kilometers. That means old car will be less efficient. That means you have to convert older car before you convert the newer car. Do you get it, guys? Let's do. Ayo, Ruben keliling ke kelompok-kelompok, diterangkan yang sudah belajar operation research. Feby, bawa bantu. Terangkan apa yang saya barusan ngomong. Okay, everyone, come on. Ayo, kamu ngerti apa tadi saya ngomong? Ngerti? Ayo, sebar. Ajari mereka biar berguna ini pelajaran. Okay, again everyone, the goal is saving, minimizing the CO2. Remember checking Professor Iwata slide. Minimizing carbon, okay, emission. Minimizing cost. Because 1 liter of petrol costs you 15,000, right? And then the decision variable is how many car need to be converted, okay? And data collection, 1 liter will cost how much CO2 emission? 1 liter, 10 kilo CO2. 1 liter, 8 kilo CO2. You have to find that data. And then old car need 1 liter for how long the distance? Newer car, 1 liter will be used for longer distance, right? And then what else? You need to find the price of electric vehicle. Electric vehicle, how much it costs, right? How long the economic life of electric vehicle. 2 more minutes and then we will continue with Pak Febi section. Mau dilanjut Pak Febi dulu, Pak Febi udah ada? Udah 2 menit lagi, langsung disuruh berdiri terus gerak-gerak sedikit supaya refresh kemudian. Okay, do you understand? Do you understand the context? No, really? Which one that you don't understand? Yeah, but from my explanation, do you understand or not? Yes, you have to search data. For example, one car, one electric vehicle costs you 500 million, for example. So 500 million times X, it less than 10 billion because you have to buy car to replace the old one. Yeah, you have to buy car and the maximum budget you have is 10 million. Not assumption. For this time, yes, it is assumption, but later you can find in the internet how much the price. It is just exercise. Just exercise. Okay. Do you understand? Still in the process? Okay, everyone. So I know that it is not easy for people with no background, but I guess we can continue later while you learn from Pak Febri. Pak Febri, Pak Fai, you need to invite them to have a bit exercise.
Hi.
Let's come back. Later you can continue your work. Now we will follow the electric vehicle section.
Okay, guys, I know the discussion is very interesting with the group, but you can continue these informations and discussions later. In the next session, we will have another lecture from Dr. Febi. So, Bapak Febi is one of our faculty member. So, maybe you can come back to your normal positions, not for the group discussion. Boleh tolong kembali ke sesinya dulu aja ya. Gini aja. Langsung kursinya aja di ini, dipindah. Oke. Okay, Fadil's group, can we start the next session? Okay, it's okay. You can continue the discussion later on. April, boleh normal kembali? Okay, Fabi, ayo di. Alright, so, hi.